In this video I'm going to be looking at the solution to question 6 of the January 2010 Edexcel D1 paper. The question is on the topic of critical path analysis. The question refers to figure 5, which is an activity network relating to a building project. It tells us that the numbers in the brackets on each arc are the times taken in days to complete each of the activities. In part A, we're asked to explain the significance of the dotted line which goes from event 2 to event 3. We're then asked to complete the precedence table and the answer booklet. In part C, to calculate early times and late times and show them on the diagram which is also in the answer booklet. And from that, in part D, to determine the critical activities and the length of the critical path. And finally, in part E of the question, we are to draw a cascade, or sometimes known as a Gantt chart, for the project. So working through those one at a time then, the first part of the question simply asks us to explain the significance of the dotted line going from event 2 to event 3. This is this line here. Now this is to do with the fact that C and D both are relying on A being finished, but that E depends on A and B. So we should say in our solution that events C and D depend on A only, but that E depends on A and B. Hence that dotted line. It's called a dummy line going in here. There's also another one you can see from 4 to 5 which has a similar purpose. We're now working through the precedence table. The first part of it we've already said, haven't we, that C and D depend on A only, but E depends on A and B. Looking at the diagram now for F, we can see that F depends on C only, so that's just this line coming here from event 4 to event 6, so the only one going into that is C. If you look at G, which is this event here, then we've got lines E and D and a dummy linking us to C as well, so we've got C, D and E. And finally for H, there are two coming into there, two activities, F and G, both coming into H, so H depends on F and G. The marking for these two parts of the question, part A, there were 2 marks, both B marks, really depending on the clarity of the explanation. And then in the precedence table, there was a B mark for getting as far as event D, and then for getting as far as F, down here an extra B mark, and a final B mark for completing the whole table successfully. In part C, we are to complete this diagram, which is in the answer booklet, with early event times and late event times. So that what we need to do is to perform what's called a forward pass, starting at this position here with a 0, and then looking at each of the events in turn. Now when we're going forwards, we want to look at the largest weight, or the longest path going forward. So that from the start to for activity A, then we can see that there's only the one, so that must be 3 that goes into here. When we're coming down to this event here, then we should look at B, which is 5, but also remembering that there's a dummy in there. Now in this case, of course, A is only 3, so that the longest path to get to this one is 5. And moving forward to this one here at the bottom, then we've got 5 plus 3, or 3 plus 2. So the 5 plus 3 giving you the 8 is the longest one there. Sorry, there should have been one more check there, because also looking along the top, we've got 3 plus 4 to get to this one here is 7. So just checking that that doesn't affect the event at the bottom. You can see that no, that 7 is smaller than 8. So you have to be careful with, particularly when you've got these dummy activities lying around, that you do look for the longest path. So checking the next one, we've got 8 plus 6 is 14, or 7 plus 5, well, that's 12, so the largest one is 14. And finally the 14 plus 2 giving you 16. Then doing what's called a back pass, or a backward pass, then we're looking this time for the smallest. We're subtracting and looking at the smallest weights. Starting at the 16, the first one obviously is only one pass to there, it is 14. Then coming back along G, 14 take away 6 is 8. And then looking at F, 14 take away 5 is 9. However, remember that we've got this dummy in here, so that in fact it's the 8 which we've written in here for G, which is the smallest value. So not the 14 take away 5 is 9, but this 8 because of the dummy in there. Working backwards to this event here, 8 minus 4 is 4, 8 minus 2 is 6. We should also, however, check before we do that, because again of this dummy, 8 minus 3 for activity E gives us an event time here of 5, but of those the smallest was 4. And then finally 5 take away 5 for B gives us 0 at this point. The critical activities are then activities which join together events which have got the same early time and late time. So the critical events and also give a difference between them equal to the difference in the times. So for example, looking at B here, we can see that the 5 in this event minus 5 gives us 0 at this event. So B is a critical activity. Tracing through the diagram in a similar way, E, because we've got 8 minus 3 is 5. G, because 14 minus 6 is 8. And H, because 16 minus 2 is 14. So those are the critical activities B, E, G and H. And the length of the path is just the number at the end here. The length of the path is 16. The question was about days, so let's put in the units, 16 days. The marking in this part of the question, there's an M1 and A1 for getting the early event time. So basically, if the numbers were increasing from left to right, then a method mark and A mark for getting it entirely correct. and then a similar M1 and A1 for the late event time. So this time if they're decreasing from right to left, then you would get that mark. A B1 mark, so simply a statement mark, no method there, and a B1 for the length of the critical path. That would follow through from any errors. So if you'd made an error in the diagram up here, perhaps got 17 rather than 16, you would be given that mark regardless. Well, the next part of the question, we're asked to complete a Gantt chart or Cascade diagram. Now these always start off with the critical path activity, so I've put those in B, E, G and H onto the diagram already, and also I've highlighted in the small diagram to right the important parts of the information that we need to complete the rest of it. I realise that the diagram is a little bit small to see on screen, but really all we need to know are the activities that we need to add into the diagram, their lengths, the early start time and the latest finishing time. So that looking at event A now, we can see that it has to start off at 0. It has got length 3, so let's mark that in. But it can finish as late as 4. So there's a float time in here, what's called a float of 1 hour. And that's usually indicated by a little sort of stick on the end. Sometimes it's dotted. As long as you have some way of showing the float that's available to that activity. So we go through these now one at a time. Looking at C, it can start as early as 3. So it's in here. It's got a length of 4, so let's mark that in. 4. But it must finish by 8. So there's again a float time of 1 day in here. D again can start as early as 3. This time it's only 2 days long, and it must also finish by 8. So a much larger float for D. And finally F can start as early as 7 and has a length of 5. So 1, 2, 3, 4, 5. And must be finished by day 14. Right, the marking here is a little bit complex. A method mark for basically getting 6 correct, with 3 of them including floats. An A mark for getting the critical path correct, or the critical activities. An A mark for getting A and C correct, and a final A mark for getting D and F correct. So it depends how much of there are in total. But there were 4 marks available for that part of the question. Well, this concludes the solution to this question. You can find solutions to other questions at www.furthermaths.org.uk.